Of all the programming languages, Go is certainly one of them. I'm not known for being a big Go fan, but over the years, I've started to come around to it a bit. Not because I enjoy writing it, I don't think that will ever happen, but because I see the value it brings to developers and to the industry as a whole. There's a lot of good things I use every day that are built with Go, like ESBuild, Vitess for handling our MySQL databases, and even Docker. There's also some bad things like Kubernetes, Terraform, and the GitHub CLI. Regardless, Go allows people to build things quickly that are relatively fast in runtime as well. I just posted this diagram on Twitter, and the response was loud, but largely agreement. The goal here was to point out the ways that all of these languages are both faster and also slower than other ones. We can see here in the runtime performance that Rust obviously wins. It's crazy what happens when you manage all of your memory yourself. But when you compare that to something like Golang, where you don't manage the memory, garbage collection handles it for you, you can move significantly faster when you're not worrying about the borrow checker and all of these individual parts. Obviously, the size of the TypeScript ecosystem and the lack of checking things, generally speaking, you can move faster in TypeScript. If you disagree with this, you haven't worked in both languages for long enough, you can move faster in TypeScript meaningfully. Your code will be slower, for sure, and even maintenance might be a bit harder in TypeScript, but the speed to go from 0 to 1 or even 1 to 10 in TypeScript is unmatched. But then we get to compilation times where Go is comically faster than all of the other options. Something that I've always been amused about with Rust is the weird reality we live in where Rust is being used to make faster JavaScript compilers and TypeScript compilers, despite Rust's compiler being one of the slowest in the entire industry. It's actually hilarious how long it takes for Rust code to build. I am regularly blown away by the speed that you don't get when you're compiling Rust code. Thankfully, both Go and Rust are being used to rethink how we build our JavaScript and TypeScript code, but I do think Rust needs to take some time to reflect on how they could speed things up on their side. The response to this was surprisingly positive. Low Level even points out that the Rust compile time issue is a very interesting and deep rabbit hole. Let me know if you want a whole video on that so I can bug him to help me figure it out. Everyone's saying developer velocity is extremely subjective. Yeah, so is runtime and compilation time. Like a really good TypeScript dev could write something more efficient than a really bad Rust dev, but I'm talking about general trends and extremes here. That's it. So if Go is right in the middle of the road or better than all of these other options, why am I not using it? Well, let's take a step back and go to when I first started trying out Go. When I joined Twitch in 2017, I was on the only team working in Elixir. It was really cool, and we were able to move super fast and build crazy stuff. The only reason our little 2.5 engineering team could build the infrastructure for all of Twitch's marathon content was what Elixir in the Erlang VM enabled for us. I was able to level up significantly as a dev, get deep into functional programming, and move faster than I'd ever moved before by working in Elixir with that team. Sadly, that team ultimately folded, and I ended up on a team working on the video infrastructure for the rest of Twitch, which was all in on Go. At the time, I hated front end. I was known as the anti-JavaScript guy. I hated the web. I didn't like building for browsers. I shot on Electron all the time. I was mostly focused on building native apps and backends. I'd done a lot of time in both Android and iOS development, but really was focused on servers. So moving to Go seemed to be the right move. And it wasn't. I was miserable. Every second I spent in that language, I hated. And I gave it a solid 2 months. And it wasn't because the language is this horrible, terribly designed thing, although we'll get to some of the design quirks in a bit. It just didn't make me feel smart. And I get it. I understand that programming is not about feeling clever and smart all the time. In fact, the desire to feel clever regularly results in really bad code being written. I'm certainly guilty of that myself, but Go never sparked joy for me. And I miss that. Because when I was in Elixir, I actually was loving it. I was, for the first time in my career, genuinely enjoying the craft of building and creating software. And then I went to Go, and that just wasn't a thing anymore, which was by design, because Go was designed to be boring and minimal, repetitive and consistent. I'll never forget the way Go was described to me by one of my first managers at Twitch. One of the specific goals of Go was that if you took 2 PRs, one from a really senior dev who'd been working in Go for half a decade, and one from a newer dev that just recently learned Go, the code would look nearly identical, which was a very strange way of thinking to me. I had never worked in a language that had that goal, making things as simple, focused in one way as possible. And then there was the garbage collector, which was a very interesting addition for a lower level language, because most of those languages had you manage your memory yourself. Usually garbage collectors were associated with languages that were much higher level, often running in their own runtimes or virtual machines like Java. So Go, feeling like C++, but not making memory your problem, was a weird mental shift that has enabled a lot of wins, but also a lot of confusion. The result's a language that doesn't necessarily fit in any one specific box. And as a result, It's been hard for me to recommend for a long time. But the more I think about it and look at it and break down the decisions that were made in its design, I have started to see the strengths, especially now that I've seen many a project try and fail to rewrite itself in Rust. A lot of my frustrations with Go are very well detailed by Faster Than Lime in his 2 blog posts about it. His 2 blog posts are titled, "I Want to Get Off Mr. Golang's Wild Ride," and "Lies We Tell Ourselves to Keep Using Golang." Both of these are great articles. I highly recommend reading them if you can. They changed my perspective on the language and, more importantly, made me feel way less gaslit because I hated my time in Go and didn't have great words for why. 2 of my favorite points in here are around types and channels. I absolutely love this quote. This quote came from OzCon, which was a conference for programming language nerds and designers. And at the time, Lime was working on designing his own language. And as he said here, he gave a bad presentation, but he fondly remembers when an audience member asked the Go team, "Why did you choose to ignore any research about type systems since the 1970s? I didn't fully understand the implications at the time, but I sure do now." Go's types are utter chaos, and the result is rough. I personally, in the tiny bit of Go I had in production at Twitch, introduced a pretty significant number of bugs. And the reason is a lot of values were nullable, but the type system just couldn't detect that. So there were multiple instances where I thought a value existed, I did something with it, but it didn't, so it failed. And there was nothing to hold your hand through that type of stuff. They handle errors great, but they don't handle empty great, unless you choose to make empty an error case, in which case, good luck, have fun. It's crazy how they got one side so right and the other so wrong. And that jarring experience felt weird because I felt at the time like I was constantly checking errors because the type system couldn't prevent them. I've since learned there's a balance here where there are errors that no type system can prevent, and having a system that encourages you to handle those errors is good, but having a type system to prevent that is also good. And they entirely failed to strike that balance in Go. The other part I hear a lot about is channels, because channels are regularly pitched to me as the reason to use Go. If you're doing concurrent things, Go is one of the best languages for it. No, it's not. The channel axioms make no sense. If you're not familiar with channels, they're the core model for concurrency in Go, and they have some weird quirks. These are the 4 channel axioms. A send to a nil channel blocks forever. A receive from a nil channel blocks forever. A send to a closed channel panics. And a receive from a closed channel returns the 0 value immediately. None of these behaviors make any sense. And I've had a lot of people try to explain them. Nonsense. Sending to a nil channel should error. Receiving from a nil channel should error. Sending to a closed channel should error. Or I guess panic, fine. That's the closest to a reasonable one. But rather than panic, why don't you just return an error? That's Go's whole thing, is returning errors all over the place. And receive returns the 0 value immediately. So there's no way when I receive from a channel to detect if it's closed or not. What? No. This is a mess. And as Lime says here, the reason is there had to be a meaning for nil channels, so they picked these ones. Chaos. There was recently a presentation about the things that Go did right and wrong, and thankfully they acknowledged the failure of their type definitions here. We define generic containers in the language proper, maps, slices, arrays, and channels, without giving programmers access to the genericity that they contained. This was arguably a mistake. We believed, correctly I still think, that most simple programming tasks could be handled just fine with those types, but there are some that cannot, and the barrier between what the language provided and what the user could control definitely bothers some people. More than bothered and more than some. I'm sure this has caused plenty of issues in the past. I know I certainly encountered plenty myself. Regardless, Lime did a great job of explaining my frustrations with Go. So why are we talking about it today? Why do I care? Let's diagram this one out because it's hard to just put into words. If you're familiar with the line of prime, this is likely going to feel somewhat familiar. On one side of this spectrum, we will say perf rules all. On the other side, we'll say dev velocity. I'll just say perf here. This is a rough spectrum where on the left here, ultimate performance is key and focus. And on the right side, dev velocity is the focus. So let's make some rectangles. We'll say there's an obvious thing that fits here. Let's say it with me, guys. C++, ultimate performance, good luck with the developer velocity. Where on the other side, we have JS and TypeScript and things like that, where the performance will not be as good, but you get really fast developer velocity. You could also put things like Python here. I'd argue Python's theoretically capable of being a little faster, and I would argue roughly the same velocity that you can get from JavaScript and TypeScript. And as you see here, just because something covers more area than other options, that doesn't mean I necessarily recommend it. Like if Python can be faster than JavaScript and TypeScript, why would I ever use JS and TS? Because I have to. It's necessary on the client. And also, it has a really good tool set and ecosystem. It makes a lot of sense to use JavaScript and TypeScript where you can, because there are places where you need to. What we're starting to see is a gap forming in the middle here. And if we were to start plugging it, we can only get so far with something like Rust. Rust theoretically can't be quite as fast as C++ unless you break a lot of its rules. C++ lets you write theoretically faster code, but it also is harder to write correctly and is more error prone. There's almost a separate axis here that I'm not going to be the one to make. And if somebody wants to make an updated version of this diagram that has an axis of reliability, go nuts. You have my support. But that's not what I'm here to talk about today. What I'm here to talk about is this giant gap in the middle here. This gap exists with a lot of the tools and technologies we talk about. I've always referred to it as the uncanny valley, and I think that's the case here more than ever. If we draw lines for this space here, uncanny valley. This is an area where the tooling isn't going to be perfect for anyone because it doesn't lean far enough in one direction. TypeScript and JavaScript will always have a crazy ecosystem reinventing how we build so that we can move faster and do really cool stuff. And that's great for people who are in greenfield projects. And Rust will always move a little bit slower and be tolerant of things like terrible compile times because their goal is performance and safety above all else. As a result, these things are very exciting and enticing because they represent extremes. And those extremes get us extremely either excited or disgruntled. And this is why those technologies get the clicks, the reach, the stars, and all the hype that they get, because they represent extremes of mindsets and extremes of needs that developers have. But there are things that live in this middle ground. And there are things you could do to make these other technologies fit here. I know that people have hacked stuff like Java to fit in here with languages that are built on top, like Scala. I know people have tried to make Ruby run faster by porting its runtime to stuff like Java. None of these solutions really filled this middle out great, though. And this is where things get interesting. This is the goal of Go, is to be this middle. And as of recent, they have pushed further this way with the introduction of arenas. In order to understand the importance of arenas, you first need to understand why there is a gap between Go's performance and Rust's performance. The reason is pretty simple. It's garbage collection. Since Go doesn't require you to deallocate memory once you've allocated it, it needs to spend some amount of compute doing that for you. It keeps track of how many references a bit of data has, and when it runs out of memory or has a spare cycle, it looks through all of the memory references, sees if there's anything in memory that isn't currently being referenced, and it nukes it. In order to do that, it has to take away some of your potential performance in your runtime in order to clean up the mess you left behind. And that is really good for the agility of you and your team as developers because you don't have to think about that problem anymore. And believe me, thinking about memory allocation will always make you slower. If there's anyone who uses Rust that says they can build generic solutions to generic problems faster than a TypeScript dev can, they're lying through their goddamn teeth because the borrow checker will always slow you down for iteration and specifically massive changes. If the architecture of what you're building changes, if the needs of your project change, if the spec changes while you're working on it, your ability to pivot and change direction with Rust is nearly zero because you have to bake so much of your intention into the code in order for everything to work. With garbage collection, there's way less code that manages all of those things, and making these changes is significantly easier. But not everything needs to have that level of flexibility. There's a lot of projects and a lot of packages and pieces we use every day that are pretty rigid, like the thing that reads a file from our system and gives us the result, like a JSON parser. A lot of these tools and technologies are pretty rigid in how they work and what they do. So having to worry about those garbage collecting constantly in the background isn't great. The Go teams never pretended that garbage collection is magic and free and not going to cause performance issues that you wouldn't have in other languages. It makes you way quicker to write code, and it's not a big deal in terms of the performance impact, but it is big enough. There are reasons why you'd want to opt out of it. This is why Go had planned to introduce a new feature called Arenas, which, as I was recording this, I learned that it's on hold indefinitely. The goal here was to allow for perfect, so to speak, performance for core packages and reused pieces like a file system reader or a JSON parser. Since those have expected inputs and outputs that aren't going to change anytime soon, it'd be a pretty good use case to not let garbage collection handle things there and just make memory safe code for the paths that are the most reused across all Go projects. I was really hyped on this proposal to the point where I was thinking a lot more about Go and taking it seriously. And that's why I'm heartbroken to have learned now that it's on hold indefinitely, because it seemed like it would solve a lot of these problems. And if we go back to the diagram, it seemed like it gave Go the opportunity to slide way further this way. And this is why I'm concerned, because Go seems perfectly happy sitting in the middle right here. And that's resulted in it not being that interesting to me. As we've hinted at a bunch throughout this and other videos, there are ways to push any technology a little bit in the other direction. With JavaScript and TypeScript, we have some really cool stuff happening with Bun, that's going to slowly expand the type of performance we can get out of our JavaScript code. With Rust, as the tools keep getting better, the education and resources continue to improve, and ideally the compiler gets faster and easier to work with, we'll see Rust getting easier and easier to adopt. But with Go, I don't know where they're going to end up. And that's the weird part for me. Let's say we start with JavaScript and TypeScript and we start to hit performance issues. Like the performance is here, but our team has now landed where our needs are at the very least here. And maybe every year our costs are getting higher, so our needs are shifting more and more towards performance. The weird part of the spectrum as it stands right now is that we start here where we just want to see if this thing works. We slide more and more, and then we hit this point where JavaScript and TypeScript might be hackable for better performance, but it's not going to be a great experience overall. And then we have a long ways to go before these other solutions make sense. And this uncanny valley is where Go is strongest. And as such, I think it's a great opportunity to continue expanding left so that the team doesn't have to change technologies. Right now, my general recommendation for companies is to start with JavaScript and TypeScript if they don't have immediate massive performance need to have something faster or more maintainable. And when they hit the point where the performance of this solution is bad enough, that's when you eat the cost and move to Rust. I drew these lines really strong, but the reality is all of these things are way blurrier than I might have led you to believe here. In fact, I would argue that these are near touching. As a result, the time you would spend in that theoretical bad zone here isn't that big. And if you know where your performance needs are, it's a lot easier to make a decision. This is also why Go is so interesting, because many companies just will never be here. For example, Twitch. Like Twitch's internal services will almost always get enough traffic that spinning them up on a JavaScript server that has really bad error management and might crash in various unexpected ways is just not a real option for you. And as such, Go allows you to compromise a little bit of that velocity in order to go way further down the spectrum of performance. But if you want something that handles every single byte in memory as efficiently as possible, Go will never be the solution for that, especially now that arenas are killed. That all said, I've seen Rust being adopted for way too many problems that fit squarely within Go's wheelhouse. A common one that I'm seeing nowadays is compilation. We have a really fast compiler for TypeScript now. It's called ESBuild. It was created by Evan Wallace during the end of his time as CTO of Figma because he wanted the JavaScript and TypeScript builds for Figma and other companies with these huge code bases to be faster. And he concluded that JavaScript was the wrong language to do that work. He picked Go as the language for ESBuild, and the result is a core piece of tooling that is used by almost every modern JavaScript solution. If you've used Vite before, Vite is built on top of Rollup and ESBuild. ESBuild in dev and Rollup in prod. That's why the reload times in dev are so fast, because ESBuild is running that through Go. Sadly, if we look at the contribution chart for ESBuild, you'll see very clearly the vast majority is Evan by like a lot. And when you compare this to other devs, like the next biggest has 4,000 lines added and 16 commits. Evan has 3,800 commits. This is a one-man band. And rather than try to fork it or build into it or build more around ESBuild, it feels like everyone's been trying to reinvent it in Rust. Now we have SWC, RSPack, TurboPack, Rolldown, which is a rewrite of Rollup in Rust. It seems like as the ecosystem realized the need for faster JavaScript compilation, we left behind one of the most valuable parts. We left behind Go. And I don't know if that was the right call. All of the Rust-based JavaScript compilers I've seen have had a really slow adoption lifecycle and even slower iteration. SWC just hasn't kept up in terms of feature additions. It's getting there, but it just hasn't gotten there yet. TurboPack has notoriously been a mess, and they've massively de-scoped the project in order to try and get it to actually ship. It seems like a lot of these projects that committed to doing what ESBuild did, but in Rust instead of Go, have ended up stuck in development hell. And I don't know how much that is to blame Rust versus the project management versus the massive goals and scope of a lot of these projects. All I can look at is the results and say definitively that ESBuild has still had the best results of anything in these tools. And I don't know why we didn't learn more from this project. I've talked to a lot of devs who work on a lot of these things, and most of them don't have a good answer either. It feels like they went with Rust because it's the best solution. And if we go back to my diagram, if you're over here, if you live in this world and you're in constant pain because of it, you're stuck dealing with these languages that just aren't fast enough for what you want to do, it makes sense that when you look over the fence and you see Rust on the other side, that's what you want to reach for and grab and use. But the fence, the thing in between the two, that thing is Go. And I'm honestly feeling a little bit of guilt because I have been part of writing that off. So I've always said, like, if you're on this side and you need to be on the other side, just go to the other side. But there's this whole space between that we ignore because we strive to jump the gap. JavaScript compilation doesn't need to be perfectly memory safe. JavaScript compilers don't need to be in a language that requires you manage every byte of memory and handle borrow checking and all of these things correctly. JavaScript compilation doesn't need to be as complex as Rust allows. And I honestly think we would be in a better place as an ecosystem if JavaScript had centralized a little more around Go instead of Rust. But I could be wrong here too. The same way I was wrong in believing Go was a bad choice for us in web dev, I might be wrong that Rust will dig us out of this eventually. It's very possible that by the end of the year, maybe even by the end of the month, we'll see a lot of those projects I was talking about before get to the point where I can meaningfully adopt them. But the harsh reality is, I've shipped ES Build in production many a time. I've never really shipped these other alternatives. I think we use the SWC compiler in Next now for some of the transpilation, but it's still Webpack at its core. I think Go has a really good opportunity in this middle ground, but again, which is kind of the theme of the video, by not being one of those extremes, Go has ended up being significantly less interesting. I'm just curious how the rest of y'all feel, because the more I've soul searched, the more I've realized that I kind of didn't give Go the credit it deserved for where it sits. And even though I just learned arenas aren't happening, and that has definitely tapered my hype around Go once again, I do think it's important to not leave behind as we learn more lessons about the tools and technologies we're building with. And I still think that just maybe we screwed up going all in on Rust when we had a good enough language right there. How do you feel about all this? And am I being too negative about Rust? If you want to watch me be more negative about it, I'll pin a video in the corner where I do just that. Good seeing you guys as always. See you later. Peace, nerds.